Yes, good day once again. As you can see on the board before us, we are on algebraic processes involving modular arithmetics. And now we are done with addition, subtraction, multiplication. We are now on division. Of all the basic operation involving modular arithmetics, the toughest one among them is division, and it's also the most interesting one. All we need to do is to keep rapt attention to all what I have to say. Once we establish the hint we need to know about this particular one, any question being given to us will be as simple as ABC. Now let's listen and listen good. In division involving modular arithmetics, these are the terms to what? Familiarize ourselves with. One, we have co-prime. Two, we have inverse. What do you mean by co-prime? For two numbers are said to be co-prime when the only divisor or the greatest common divisor between them is 1. E.g., 3 and 5, 3,5, GCD of 3,5, GCD of 3 and 5 is what? 1. The D here is what? 1. The only number that can divide both 3 and 5 is 1. We also check again 2. GCD of what? 4,7 is also what? 1. So these two numbers are co-prime. Now, remember we said that we have GCD. In Nigeria, it is called highest common factors. In some other part of the world, it is called what? Greatest common division. That's what we mean by what? GCD. Greatest common division or divisor. Now we talked about inverse. For a number to be a divisor in modular arithmetics, it must have an inverse. What does this inverse mean? In ordinary mathematics, it is called reciprocal. That means if you have, let's say you have number like 3, the reciprocal of 3 is what? 1/3. If you have number like 4, the reciprocal is 1/4 in that form. But in this case, we can't use that. What we need is an inverse. That is a number that can divide the divisor. That is what we mean by inverse of that number. Now, let's look at this. Another point, we talk about co-prime. Let's highlight our point. Note, Like you are the that's why I go. The point is a what? Confirmation of what? GCD, then multiplicative inverse, once these two are ascertained, there is a solution to that particular division in modular arithmetic. However, we could be given questions like this. Let's say you have 4 and 6. Here, you have more than one GCD. 1 is one of them. 2 can divide 4. 2 can also divide 6. That means your GCD, they are now up to 2. In this case, we are going to employ the service of a theorem called CRT, which is Chinese remainder theorem. But for now, let's tackle the question that involves the one that has one GCD for now. When we are done with that, in the next video, we'll show you how to apply CRT to solve question involving modular arithmetics under division. Now, let's see example 1. Let's say we have simplify seven divided by 5 mod 12 solution. The question was 7 divided by 5 mod 12. If you look critically, 5 here is what? Divisor. It is this divisor. Divisor must have inverse for the expression to have solution. Otherwise, it has no solution. Now, we have what? 7 is called what? Dividend. And the 12 is what? Modular. Now, we're asked to find the 7 divided by 5 mod 12. What do? Simply we look what? Find our GCD, which is what? Between the what? The divisor and the modular, 5 and 12. What number can divide 5 and 12 together? The only number is what? 1. Remember, we said for us to what? Forge ahead, the GCD must be 1. Now, the GCD is what? 1. Having gotten this, we'll now look for what? The inverse. Find the inverse. Let's make it step by step. Step 2. Step 2. Find the inverse of the divisor. Now, why are we looking for a divisor? We will find the inverse of our divisor, which when we multiply together and divide by the modular, it will give us 1 mod 12. Since our modular here is what? 12. Now we have to start looking for it. Say 5 times 1 is what? 5. 5 times 2, 10. 5 times 3 is what? 12. 12 in 12 is 1 remainder 0. Meanwhile, our remainder here is what? 1. So we try 5 times 4. That is what? 20. 12 in 20. That is 1 remainder 8. Higher than the what? This. 5 times 5. That's 25. That's what? 25. 5 in 25. That is what? Sorry. 12 in 25. That is 2 remainder 1. This go along with what? This value of GCD. Therefore, the inverse of 5 is 5. The inverse of 5 is 5. You pardon me to use the other part of the board. Now, we can now say, okay, the inverse of 5 is 5. So we can now come up here and say what? Multiplicative inverse, dividend times what? Our inverse, which is this, mod 12. 7 times 5 is what? 35 mod 12. 12 in 35, remember, 12 times 2 is 24. 12 times 3 is 36. More than what? The value. So we do what? We look for 12 times 2, which is 24. 1, 1. So it means we have what? 11 mod 12. Therefore, we can say 7 divided by 5 mod 12 is equals to 11 mod 12. This is what we are asked to do. You can see it's totally different from what normal division that you know, because if this mod 12 is not here, we would have had 7 divided by 5. We would have said, okay, we have 1 point certain value, but look at what you have, 11 mod 12. This is what makes this particular subtopic of modular arithmetic very interesting. Don't forget to follow us on our Facebook handle, Aminu Maths Class, our YouTube channel, our TikTok handle, the same Aminu Maths Class, our Instagram page, Aminu Maths Class. We'll bring out or some more questions still on this topic in our next video. Just stay still. Thank you and bye bye for now.